A suitcase-sized satellite on the moon's far side could finally listen to the universe's first 150 million years of silence. This is Fascinating Frontiers, episode 169. NASA's Roman Space Telescope carries coronagraphs and wide-field instruments designed to block starlight and reveal planets orbiting other stars. The observatory will measure the light from these worlds across multiple wavelengths to determine their sizes, orbits, and atmospheric makeup. Roman's large field of view will let it survey thousands of stars simultaneously. Follow-up observations from the ground and other telescopes are already planned once the first data arrive after launch. The mission's exoplanet tools build directly on lessons from earlier observatories that first demonstrated starlight suppression at scale. While Roman looks outward for new worlds, another major program is preparing humans to travel farther than they have in decades. President Trump will present the Congressional Space Medal of Honor to the 4 Artemis II astronauts on August 28 at Johnson Space Center. The award recognizes their upcoming flight around the moon as the first crewed mission beyond low Earth orbit since 1972. The ceremony highlights the return of American astronauts to deep space and the international partnerships supporting the mission. Details of the event were released by NASA this week. The medal underscores the crew's role in validating systems needed for later landings. This development continues the steady progress toward crewed lunar return that we have been tracking in recent episodes. While crewed exploration also depends on quiet scientific outposts, a small satellite is soon heading to the moon's far side. The UK-built CosmoCube is roughly the size of a carry-on suitcase and will operate from the lunar far side. Its radio antenna will search for the faint 21-centimeter signal emitted by neutral hydrogen during the cosmic dark ages, the 150 million years before the first stars formed. Placing the satellite behind the moon shields it from Earth's radio noise. Scientists expect the data could reveal how the first structures in the universe began to glow. The mission targets one of cosmology's longest-standing observational gaps. The moon's far side offers a natural radio-quiet zone roughly 3,500 kilometers across. A receiver placed there can detect signals billions of times fainter than anything reachable from our planet's surface. CosmoCube will tune to the 21-centimeter wavelength emitted by neutral hydrogen atoms, a line stretched by the universe's expansion into the low-frequency radio band. During the 150 million years before the first stars turned on, this hydrogen filled all space at a temperature of only a few Kelvin above absolute zero. The spacecraft must maintain extreme thermal stability because even a 1-degree shift in receiver temperature can swamp the cosmic signal. Yet the exact timing of when that hydrogen first began to glow remains one of the largest open questions in cosmology. While one mission listens for the universe's earliest signals, another is tackling the growing problem of orbital clutter closer to home. The UK Space Agency awarded ClearSpace a £61.3 million contract to capture 2 defunct UK satellites in low Earth orbit by the early 2030s. The mission will attempt the first removal of unprepared, uncooperative targets without docking fixtures. Starfish Space also reached the final stage of the competition alongside Astroscale. The 5-year project marks Britain's first national active debris removal effort. Both target satellites are fully passivated and lack any capture aids. Governments are also expanding their view of Earth itself, driving a surge in observation satellites. Nova Space forecasts more than 6,500 Earth observation satellites will launch by 2035, generating $155.9 billion in manufacturing revenue. Governments are driving the growth through expanded sovereign intelligence and environmental monitoring programs. The projection covers both government and commercial constellations. Manufacturing demand is expected to remain strong across multiple orbital regimes. National pride in space also shows up closer to home, as one Canadian astronaut recently reminded the public. Astronaut Jeremy Hansen opened the Canadian National Exhibition and spoke about Canada's contributions to space exploration. He emphasized ongoing work on the Lunar Gateway and future Artemis missions. The appearance drew attention to Canada's robotics and astronaut programs. Hansen's remarks connected current national efforts to the broader Artemis architecture. Back on Earth, new findings are reshaping how we understand mysterious repeating radio signals from space. New observations show that at least some long-period radio transients originate in cataclysmic variable systems, where a white dwarf and red dwarf orbit closely. The signals are polarized and coherent, resembling pulsar emission, but repeating on longer timescales. Researchers used radio and X-ray data to match the timing and polarization properties to known binary systems. The finding narrows the possible explanations for these mysterious repeating sources. At least one transient now has a confirmed cataclysmic variable counterpart. While some signals come from exotic binaries, others may come from much closer to home. Laboratory tests show certain Earth microbes remain viable after exposure to simulated lunar conditions, including vacuum, temperature swings, and radiation. The results raise questions about forward contamination risks for future missions. Researchers stress that sterilization protocols will need refinement before crewed landings. The study used realistic regolith analogs and radiation doses expected on the surface. Health risks extend beyond contamination. The integrated medical model completed probabilistic simulations for crew health events during 31 to 180-day lunar orbit and surface stays. Separate runs covered shorter and longer mission durations. The tool helps planners decide which medical supplies and training are most critical. Monte Carlo methods incorporate historical flight data to generate risk distributions for each scenario. Similar updates have also refreshed risk assessments for long-duration stays in low Earth orbit. NASA refreshed its integrated medical model outputs for 31 to 400-day stays in low Earth orbit. The new runs incorporate recent flight data on respiratory and musculoskeletal issues. Mission planners use the results to refine exercise and countermeasure schedules. Updated probabilities directly inform kit contents for future commercial and government crews. The August 22 astronomy picture of the day shows a sky dominated by Perseid meteors streaking across the night. The image highlights the annual shower's bright, fast trails against a backdrop of summer stars. Viewers are encouraged to watch for lingering meteors in the days ahead. The picture compiles multiple exposures that emphasize the shower's characteristic swift paths. Photographer Kwa Xiaofeng traveled to high-altitude grasslands in Sichuan province to record the Geminid meteor shower. The wide-open site at over 11,000 feet offered dark skies for time-lapse sequences of the annual December display. The resulting images show dozens of meteors against the winter Milky Way. The location's elevation reduced atmospheric interference for the long exposures. Before we go, keep an eye on the next set of medical model updates as NASA refines plans for longer lunar surface operations. That covers today's space and science news. Share this with a fellow space enthusiast if you found it interesting. I'm Patrick in Vancouver. See you tomorrow. And if you'd rather watch than listen, find us on YouTube at NERA Network. Links in the show notes. And before you go, this show is part of the NERA Network, a family of daily podcasts on tech, science, and markets. Each one a short, sharp briefing you can finish on the commute. If today earned its place in your feed, here's your next listen. Models and Agents, your daily briefing on AI models and agents. Find every show free at neranetwork.com. And on the website, every episode's visuals live in our free image gallery at neranetwork.com/gallery. Royalty-free under Creative Commons. Download with attribution. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.